In this video, we're going to demonstrate the assembly, operation, and disassembly of the Tadano 440-ton CC24.400-1. This lattice boom crawler crane is a small, big crane, making it perfect for tighter locations, offering you the power and versatility you need for your toughest jobs. This crane features our optional quick connection for superstructure and car body, so it can be easily assembled and disassembled for flexible transport from job site to job site. The crane has a load capacity up to 440 US tons and a maximum load moment of 37,380 kip feet, making it perfect for large-scale infrastructure, energy, and construction projects. This crane has a basic boom length of 78.7 feet and a maximum boom length with luffer of 551.2 feet. The CC24.400-1 is available in a number of different boom configurations to meet your construction needs, including fixed fly jib, luffing fly jib, and superlift. The working weight of the CC24.400-1 is 518,200 pounds and is powered by a 375 horsepower Mercedes-Benz diesel engine. The working speed for hoist 1 is 492 feet per minute, and hoist 2 is 426 feet per minute. The single line pull for both hoist 1 and hoist 2 is 33,709 pound-force. Both drums can be synchronized, allowing for less rope per drum and faster block speed with higher parts of line. The travel speed is 1.24 miles per hour. The overall length of the crawlers is 33 feet and 8 inches. The width from outside to outside of the crawlers is 27 feet 9 inches, and the width of the standard crawler shoe is 47 inches. The CC24.400-1 will transport with crawler frames removed and will be shipped from the factory in these major components: the superstructure, car body, crawler frames, counterweight trays, counterweights, and boom sections. Additional support materials will be shipped in sea containers. The transport weight of the superstructure is 136,300 pounds in self-assembly mode and has a total length of 42 feet 4 inches. The car body with jacks is 50,700 pounds and the standard crawlers are 57,100 pounds each. The Tadano CC24.400-1 has the power, versatility, and flexibility that you need on your job site. At Tadano, safety is a part of everything we do. In this video, we will highlight a number of safety features throughout this video to help keep your personnel safe. Every Tadano crane is equipped with anti-fall protection, as well as our patented lorry fall protection system. These features can be found in your instruction manual under Personal Protective Equipment, PSA. It is important that you review and understand these safety features. You will also notice a number of decals and logos around the crane. It is important that you recognize and know the dangers associated with each, as well as hand signals for safe operations. Now, let's start with the assembly process. The crane will arrive in a number of components, including the car body, the superstructure, tracks, counterweight trays, counterweights, boom sections, blocks, and sea containers, with various components necessary for crane operations. Before you get started, it is important that all pins and bore holes are cleaned and greased. Check couplings for missing or damaged O-rings, and check that electrical connections are clean and dry. Before you start the assembly process, make sure that you have sufficient space to assemble the basic crane and to fit and erect the boom. Ground conditions must be sufficient to support the weight of the crane, and it must be level. In this video, we will be highlighting the self-assembly process. It is important that you always refer to the instruction manual during the assembly process. In this example, the crane had already been delivered to that job site and placed on wooden cribbing for support. To get the car body ready to receive the superstructure, we will first need to set all 4 outriggers to lift the car body and for stability. Unpin each outrigger from the transport position and swing the outrigger outwards. Remove the support bar and pin to the outrigger and car body, making sure to insert keeper pins. Lift the outrigger's hydraulic cylinder to the upright position and pin. Remove the outrigger plates from their transport position and install all 4 outrigger plates. For suitable ground pressure and for stability, we will add hardwood blocks with an approximate height of 12 inches under each outrigger. In this example, an auxiliary crane was used to lift the car body and to place it onto the position blocks to prepare for the superstructure installation. Next, we will install the superstructure to the car body. Connect the slings to the superstructure using the supplied shackles attached to the designated connection points on the superstructure. This will help balance the superstructure and not damage the superstructure during installation. In this example, we used 2 assist cranes, but this operation could be completed with just 1. Slowly lift the structure over the car body, aligning the superstructure to the alignment pin on top of the car body. Before setting the superstructure on the car body, all electrical and hydraulic cables will need to be connected. These connections will need to be made in the center opening of the car body. Here, you will need to connect the hydraulic hoses based on their labeling. Check each carefully and make sure they are tightened to the proper tolerance. You will also need to feed the electrical cables up to the superstructure for power and communication. At this point, you can start the engine to get power to the car body. Using the handheld remote control, level the car body using all 4 outriggers. It is important that the car body is level, so the superstructure mounts properly. Once this process is complete, lower the superstructure onto the car body, making sure that the guide pin and locking notch is in place. Using the remote control, you will need to expand the locking ring into place. Using a socket, tighten this screw until the locking pin appears. Lastly, while you are in the center cavity of the car body, secure this rod to the superstructure and down through these forks. This is very important as it connects the cable harness of the car body to the superstructure, ensuring that the harness rotates with the superstructure. Next, we will swing the cab into the operating position. For transport, the cab is swung in front of the superstructure. To swing the cab, remove the pin holding the cab in the transport position. Then slowly rotate the cab to the operating position and pin securely. Then, using the tightening rod, make sure that the cab is secure. To make sure that this bar does not loosen, use the locking ring. For safety, the next thing that we need to do is install all the catwalks and railing. To do this, you will need to remove the keeper pins and raise each to its full and upright position. Please be careful as the hinges can be potential pinch points. Once the catwalks are in place, install all the side rails. Now you are ready to safely continue the erection process. We will now need to raise the A-frame and fold into the assembly position. First, remove the transport pin from the cylinder. You will then remove the rope guards from the front of the 2 sheave sets. These guards will be reinstalled after erecting the boom. Start the engine and switch the LMI to RGO. You will then activate the radio remote control and pre-select the assembly function. Press buttons 1 and 7 to extend the cylinders to swing over the A-frame until the derricking ropes are tensioned. This will be at about 8 degrees. From here, we will need to use control lever 3. Move lever forward and slowly raise the A-frame with the cylinders until they are fully extended. At this point, you will continue to lower the A-frame using the derricking gear with control lever 3 until the A-frame reaches a position of approximately 25 degrees. Next, we will be adding the central ballast weights to the car body. In this example, we will be using the self-assembly mode. You will need to lower the mounting hydraulic cylinder on the A-frame and attach the supplied lifting chains and slings. It is important to note that for self-assembly, these weights must be within an 18-foot radius to safely be lifted onto the car body. The maximum A-frame angle is 62.7 degrees. The maximum permitted load is 25 tons. The slewing area of the superstructure is 360 degrees. After the lifting slings are added, loop the slings around the lifting connection on the ballast. Slowly guide the ballast onto the mounting hooks on the car body. Insert both pins and keepers. Then rotate the superstructure and place the ballast on the rear side of the car body. Please note that with the first ballast on the front and back of the car body, your maximum radius is 19.69 feet. The maximum A-frame angle is 59 degrees. The maximum permitted load is 27 tons. The slewing area of the superstructure is 360 degrees. Once the ballasts are set, we will install the track carriers. Please note that you cannot have counterweight mounted onto the superstructure at this time. The A-frame must be positioned to the front, and track frame lifting can only be done using the A-frame mounting cylinder, not with the derricking gear. With the ballast installed, your maximum lifting radius is 19.7 feet, so it is important that track frames be positioned during crane delivery within this radius. First, we will install the left side track. On the LMI, activate the SMAB1 configuration. Before lifting the crawler frame, the cab of the superstructure must be tilted back. Make sure that the A-frame assembly cylinder is hanging in the center of the crawler track carrier. Secure the slings to the designated connections on the crawler side frame using the supplied shackles. It is important to only attach to the designed connection points to prevent damage to the tracks. Once the connections are secure, slowly retract the assembly cylinder by moving the control lever 3 until sling ropes are tensioned. Carefully position the protected sleeves that are mounted on the slings between the track pads to protect against damage during lifting. Note that free lifting of the track frame within the derricking gear is not permitted, and you must adhere to the lifting guidelines. Now we are ready to install the crawler track frames. Slowly lift the track using the assembly cylinder. Align the holes of the track frame and car body until they are flush. Activate the radio remote controller and pre-select assembly function, assembling car body on the IC1 unit screen. Press the 2 and 10 buttons on the controller and the pinning cylinders on the left-hand crawler track will extend. Once fully extended, remove the security cap from its holding position on the track carrier and secure onto the pin. Then secure the electrical connection from the track to the car body. Lower the assembly cylinder using control lever 3 so that the lifting tackle can be removed. Repeat this operation to install the crawler track frame on the right-hand side of the car body. Next, you need to make the hydraulic hose connections from track to the car body. Here are a few points that must be observed before connecting the quick-release couplings. First, the engine must be switched off, and all pressure must have been released from the hydraulic system. Make sure to connect all quick-release couplings with the hydraulic lines that are marked accordingly. Once the tracks are installed, all 4 outriggers can be retracted and stowed. Then install the second ballast weight to the front and back of the car body. We are now ready for the superstructure counterweights. We will be installing 10 counterweights, 5 counterweights on each side of the superstructure, but first we will need to install the supports. Using an auxiliary crane, lift the support and hook onto the head bearing on the superstructure. Carefully lower the support until it is flush with the superstructure. Secure underneath with locking pin and linch pin. For safety, stand up the handpipe on the counterweight support and secure. Unshackle the support and then proceed to hang the opposite side using the same procedure. Once both supports are hung, we will start adding counterweight. It is important to note that you must only stack counterweight plates, 1 or 2 at a time, alternating sides of the superstructure. This prevents overloading one side. General rule is to start with 1 plate and then add 2 at a time, alternating sides. The counterweight plates are secured together using cams and grooves to prevent the plates from slipping out of position. After each counterweight has been fitted, it must be checked to make sure that it is in the correct position. Following assembly, the entire stack must be checked to make sure that it is in the correct position. To secure the counterweights, Tadano uses an assembly chain, which is lowered through the openings in the counterweights and is attached in the hook on the bottom of the counterweight support tray. The locking plate on top of the counterweights is secured into place using tension with clamping bolts. Once the counterweights are attached, we are ready to assemble the boom. Although this crane can be used in a number of different boom configurations, for this example, we will only be adding the boom foot, one section of boom, and the head. As always with Tadano, safety comes first. To help keep personnel safe, first raise all the side rails on the boom foot and pin into place. Once this is done, connect the shackles and lifting ropes to the designated lifting points on the boom foot. This will help with balance and to avoid any damage to the boom foot. Slowly pick up the boom foot and guide into the superstructure, being careful not to damage any components or the cab. Activate the radio remote controller and then select Assembly Main Boom Foot section on the monitor of the IC1 system. In this example, we use the mobile hydraulic power pack to install the pins. This helps reduce the damage to the pins for longer life and ease of operation. First, connect both quick connect hoses to the hydraulic pin activators. Remove both locking pins and make sure to open the stop valve. Once this is confirmed, push both pins into the boom foot section of the superstructure. Insert locking pins and secure and close the stop valve. You will need to lower the foot section onto a hardwood base that is approximately 2.62 foot high. Once the foot is secure, we will need to move to the first section of boom. For safety, we will first need to install the anti-fall protect system. This is available on all Tadano boom sections. Detach cables and pins from the support bar. Using the supplied pole, raise the support and pin in the upright position. Pin the support cable to the base of the boom. This will keep the cable tight on the upper supports. Once both support bars have been raised and secured, personnel can hook in, helping protect against falls and injury. This system must be used while walking along the catwalk or working on the boom sections. In this example, we installed the head to the boom section, before we installed the boom section to the boom foot. To do this, connect the shackles and lifting ropes to the designated lifting points on the boom section. This will help with balance and to avoid any damage. Then raise the boom section. You will then need to lower the 2 support legs for the boom section and place on wooden supports. As always, never walk under a suspended load. To lower supports, unpin the support and lower using the hand crank. Once the support is completely lowered, insert the pin and secure. Repeat the process on the other side. Then lower the boom onto the blocks. This will hold the boom section up to install the head. Next, connect the shackles and lifting ropes to the designated lifting points on the head. Slowly lift the head, checking for balance. Then line up the upper pin locations first. Insert both pins and keepers. To do this, we use the mobile hydraulic power pack. Then lower the head into the boom pin bore openings and insert pins and keepers. Now you are ready to pin the boom section and head to the boom foot. To do this, rig the slings to the bottom section at the appropriate connecting points and slowly lift into place. Please remember that no personnel should be under a suspended load at any time. Line boom section up to the boom foot. You will first insert the top pins, then lower the boom, and insert pins and keepers. We will now need to pin the stay bar to the A-frame. First, we will make our connections to the head. To help raise the bar into position, Tadano has installed a lifting bar. By pushing the bar, you can raise the stay bar and allow personnel on top of the boom to align and pin to the stay bar to the head. You will now need to pin each section of the stay bar and finally pin to the supports on the A-frame. Slowly raise the A-frame until the stay bar has tension, making sure that pins do not get snagged. Do not raise the boom at this time. With the boom fully supported, we will need to connect all electrical and communication cables. To do this, unlock the necessary spools and string the cables to the desired length. Make all connections to the superstructure. Secure cabling to the boom and tighten by spool and lock into place. Connect all hydraulic hoses to the superstructure, making sure that all connections are tight and secure. Next, we will reeve the rope. To do this, use the auxiliary reeving hoist. But before we start, lower the cable guide on the bottom side of the boom foot to protect against damage. Then make sure that you remove the top and bottom cable guards from the head. Using the left joystick, slowly release the rope off the auxiliary hoist, making sure to keep tension on the rope. You will need to pull a sufficient length to pull over the boom head. Lower a rope or guide to help pull the reeving rope up and over the head. Then walk the rope down the boom section to the main drums on the superstructure. Connect the reeving rope to the rope on the main drum. Slowly reverse the reeving drum. Synchronize with the main drum to keep even tension on the reeving rope. Reeve the rope over the head and through the proper sheave, making sure that you have enough rope to reeve the block. Then repeat this process for the second drum. Add the rope guards back onto the head and secure. Next, we will be lifting the head over the block. Please note that before erecting the boom, always check that all bolt connections have been secured and that no tools are lying on the boom. We will now need to connect the block. First, feed the rope through the appropriate sheave in the block. Then lay the rope end into the rope socket and pin into place. Lift both connections for the main and secondary drums to the bottom side of the head and attach. Add the anemometer and connect electrical connection. Then slowly raise the boom, checking that all ropes are feeding correctly and all connections are secure. Install the anti-tube block over the block for safe operations. We will now add the block level sensor. Next, extend the backstops for the boom. Then switch on the diamond in the right D-log so the IC1 system understands that you are erecting the boom. Before the boom system is erected, all limit switches, angle detector, anemometer, and aircraft warning lights must be checked. Once verified, change the LMI to the SH mode, and we are ready to lift the boom. Lift the boom and make sure the backstops are in position. We are now ready for operation. This section will illustrate the cab and operating controls. The first thing to notice is how large this cab is. In the front of the cab are two large screens that are the IC1 or Intelligent Control System. These screens can be easily moved around for better visibility or to store for transport. The IC1 features bright LED screens that can be seen easily even on a bright sunny day. The features of the IC1 will be highlighted in another segment. Behind the IC1 is a large front window that opens out, adding great visibility and ventilation. In the front of the cab, there are 3 ventilation outlets. Combined with the vents on each side of the seat keeps the operator comfortable year-round. Below the IC1 are 2 foot controls and a foot push button. The right pedal is for speed adjustment of the engine, and left pedal is to release the slew brake. If you push down, the slew is closed. In the up position, the slew is open. This foot switch is the horn, and this one is the override switch. The operator can assign which function they would like to override using the LMI. Above the IC1 are video monitors that show drums H1 and H2. These are important as it gives you complete visibility to the operation. Next, we will move to the operator's seat. This seat is fully adjustable for those long days on the job site. To slide the seat forward, pull up the lever at the bottom of the seat near the floor, and simply slide forward or backward to set the desired position. Above this is the weight adjust. To adjust, turn left and right to decrease or increase support. This is important when there are multiple operators that are various shapes and sizes. This red button is for the seat heater, which helps on those cold days at the job site. Next is the setback adjustment. Pull this up to adjust and release once the back is at the desired position. The seat also has adjustable armrests, so the operator can place their hand in the correct position for safe and comfortable operation. To make armrest adjustments, lift the rest and spin the knob on the bottom, left or right to move to the correct position. Below the left pilot control is a handy drink holder, as well as a small storage compartment that can be used for various equipment or manuals. Next, we will look at the control levers. These ergonomically positioned levers control the full operation of this crane. On the right-hand side of the seat, there are 2 controls. The far right lever controls H2 raising and lowering of the hook, the self-assembly cylinder, the derricking gear, and the right travel gear. Pull back to raise and push forward to lower. For the left lever, this button is used to enable the free swing for the superstructure. And this button is for H2, high-speed mode on and off. High-speed mode on and off for H1 and H2 synchronous lifting, the derricking gear high-speed mode on and off, and the travel gear high-speed mode on and off. The left controller controls H1, raising and lowering the hook, synchronous hook lowering, and luffing gear W2. This lever is also used for the left travel gear. Pull back to raise and push forward to lower. For the left lever, this button is for H1, high-speed mode on and off. High-speed mode on and off for H1 and H2, synchronous lifting. The luffing gear W2, high-speed mode on and off. And the travel gear, high-speed mode on and off. And this button is to enable the slew gear. Each of the levers have a rocker switch at the top. This controls the operating speed of each function, from 100% to 20% of maximum speed. The amount you select can be seen on the operating screen of the LLD. The small red button behind the rocker switch is the vibrator coil, which allows the operator to feel the rotation of the winch. Lastly, at the front is the enable control or deadman switch. When engaged, all controls are non-functional. There is also a deadman switch in the seat. Next, we will move to the control lever on the left-hand side of the seat. This control has a number of different functions, which are controlled through the LLD. This includes derricking gear, luffing W1 and W2, simultaneous travel gear operations, the slew gear, the reeving winch, the hydraulic cylinder for A-frame and connecting system to counterweight dolly. This lever also has two buttons on the top. The first is for high-speed mode on and off for derricking gear, luffing gear W1 and W2, and the travel gear. And the other is used for increasing the pressure to the slew gear. Please consult the operator manual for settings and more details about using all the pilot controls. Before we leave the seat console, we need to point out the switches on the back side of the consoles. All but one are optional. The first and most important is the cab tilt switch, which is located on the right-hand side. This switch will have to be used during the assembly and disassembly process when installing or removing track carriers. This function can also be useful for the operator to improve the visibility up to the top of the boom. The cab will tilt up approximately 20 degrees. Please note that when tilting the cab, the side door must be locked in the closed position or completely open. Now let's look at the far right-hand side of the cab. At the front is the AM/FM radio for the operator's comfort. Next is the quick stop switch for emergency situations. Below this is the key switch. Right turns the voltage to components on, left to turn off. It is important to turn on the switch to supply power, then wait until the LLD appears before starting the engine. Once the crane is powered up, use the engine start switch. The engine stop switch is located next to the start switch. Above these two switches are the window wipers for the front and roof. The third switch is for water. This yellow switch is for automotive driving. The lower rotator switch is for engine speed adjustment, and the upper is for controlling instrument illumination. Next to these rotating switches is the toggle switch for the rotaflare light, which is one of the many safety features throughout this crane. The toggle switch above is for the DPF regeneration system. This can be in locked or manual modes. Here is the aircraft warning lighting switch. This must be turned on when working at night for aircraft safety. Above this switch is the dashboard illumination switch, which helps the operator during nighttime operations. These four toggle switches are the lighting around the crane. The first is for the exterior light in front of the cab. Above that is for the superstructure. This light is for the interior of the cab, and the last is for the winch. The next two switches are optional. The lower switch is for the central lubricating system for the superstructure. This system is very helpful to make sure the superstructure stays lubricated at all times without having to manually grease components. The top switch is for optional battery isolation. The next two switches are very important during those hot summer days. They are the air conditioner and the cab ventilation system. The rotating switches next to the air conditioner controls the fan speed, and the other is for temperature control. The last two items on this panel are two sockets. The first is the cigarette lighter, which is 24 volts, and the second is a standard 12-volt socket for power supply for various items like cell phones. Lastly, there's a small adjustable light that is perfect for reading load charts or the operator's manual. The box to the far left of the cab is the wireless receiver for the emergency control system. Please note that during emergency operations, the load limit device is not functioning and can only be used to lower the load to the ground. The IC1 and the emergency control system cannot be used at the same time. For an in-depth description of all the functions of the pilot controls and the location of switches, please check the operator's manual. This section will cover the location of a few exterior components on the Tadano 24.400-1. First, behind the cab is the tank for the window washer, which services washers for the front window and the top window. This helps improve the operator's visibility out of the front of the crane and up to the top of the boom. The air conditioner for the cab is next, which will keep the operator cool and productive in the summer. And for emergencies, there is a portable fire extinguisher. On the top of the cab is a rotaflare flashing light. This can be used to alert personnel that the crane is in operation. To switch this light on, use this switch in the cab. Next to the rotaflare light is the safety warning light, which displays the load utilization. For loads within the permitted range, 0 to 90% of load utilization, the light will be green. For loads within the advanced warning range, 90 to 100% of load utilization, the light will be yellow. And for loads that are above 100% of the crane's load capability, based on the LMI parameters, the light will be red. The blue light indicates the remote control is active. The work light is next, and is part of a series of work lights throughout this crane, which includes the top and front of the cab, the rear of the superstructure, as well as the boom. This offers the operator visibility, even during nighttime operations. The switches to turn on these lights are in the operator's cab. There are also a number of cameras throughout the crane, so the operator always has great visibility of crane operations. The last item on the top of the cab is the wireless antenna that is connected to this box in the cab. This allows for remote connection to the remote controller or the emergency controller. Consult the operator's manual for remote or emergency operations. On the side of the superstructure, there are two hydraulic levers. The first is used to control the left and right boom backstops. The second lever is to extend the superlift mast cylinders. Below this area is the battery compartment, which has battery isolation capabilities, which are optional. Use this switch in the cab down to isolate the battery from the crane's electrical system. Press up to reactivate. Check your operator's manual for more instructions. Next to the battery compartment is the emergency operations system. Simply remove this panel to expose the drive motor and hydraulic pump connections. Once the hoses are connected, use the mobile control panel to put the crane in a safe position. Make sure to consult the operator's manual for instructions on use of the emergency operations system. On the top side of the superstructures are the drum motors. The standard configuration for this crane includes hoist 1, hoist 2, and the boom winch. These drums are powered by hydraulic motors through a closed planetary gear unit in an oil bath. All the rope drums have spring-applied, hydraulically released multi-disc brakes and non-wearing hydraulic braking for load lowering. Hoist 1 and 2 are removable to reduce weight during transport if necessary. Between the hoist drums and boom winch are all the hydraulic pumps and engine components. The easy-to-remove panels offer complete access to all these components, including routine maintenance checkpoints. In addition, on the underside of the superstructure, these panels can be removed so there is complete access to all engine components, including the engine oil plug, radiator, and radiator fan. There is also easy-to-clean radiator screens. The panels are replaced by simply sliding them back in place and securing. At the rear of the superstructure are the counterweight trays. In this configuration, we will have 5 10-ton weights in each tray. These weights are held in place by a support chain, which is secured to the top of the counterweights. This crane also allows for superlift with additional counterweight trays with a maximum configuration of 160 tons. Please consult your operator's manual for more information on the superlift capabilities. There's a warning alarm to warn personnel that the crane is rotating. The exhaust for this crane is on the opposite side from the operator, keeping the exhaust and heat away from the cab. At the front of the superstructure are the hydraulic and electrical connections for the boom, as well as the reeving winch, which is used during assembly and disassembly. On this crane, there is an optional automatic greasing system. There are a number of these systems installed throughout the crane to continuously grease key components. If the crane is not equipped with this system, it is important to routinely grease each of the key components. Lastly, the car body is a welded box-type construction that is fabricated from high-strength, fine-grained structural steel. It is designed to be bending and torsion-resistant, making it an excellent platform for this crane. Attached to the car body are the central ballast weights, 2 in the front and 2 in the rear, each weighing 10 tons. Attached to the car body are the track frames. The length of the track is 33 feet 8 inches, and the track shoes are 3 feet 11 inches wide. The width from outside to outside of the crawlers is 27 feet 9 inches, giving this crane a wide, solid base with plenty of track on the ground for stable lifting operations. For added stability during superlift operations, optional outriggers can be installed to the track frames. The powertrain is a hydraulic motor through a closed planetary gear reduction unit running in an oil bath. The units are extremely compact and are designed to fit within the width of the crawlers. To adjust track tension, the track crawler has this compartment that can be opened to increase or decrease track tension. In addition, plates are available as well. The maximum travel speed for this crane is 1.24 miles per hour. For more information on the components and specifications of this crane, consult the Tadano CC24.400-1 datasheet or the operator's manual. In this section, we will cover the Tadano IC1, or Intelligent Control System touchscreen monitoring system that are designed as an integral part of the crane's operation. The display provides critical crane monitoring information on one screen and operating limits on the other. These screens can be assigned based on operator preference. This system provides audio and visual signals as the load or the radius approaches maximum limits and stops crane functions when the limit is reached. The main monitor display inside the operator's cab consists of 2 monitors. These monitors are stored on the right side of the cab during transport and can be easily moved into place. Now let's look at the IC1 operation. Both screens are touch screens, so it's very important that you use a dry, clean finger, glove, or suitable touchscreen stylus to operate. Once the ignition is turned on, you will see the menu screen. At the top are icons for system settings, background illumination, setup crane type, and setup display. The second row is LLD screen, operating mode selection, operating range limit, and fault code. The third row is for eye parameters and info, and the fourth line is for service items. The system setup icon will get you to this screen, which shows the overall setup for the IC1, including language preference, save changes, and exit. Next, we will look at setup display. Hit OK. It is important to make sure that the IC1 is set to the current crane configuration before you begin operation. The system will save these settings even if the crane is turned off. The operator should check the settings each time the crane is restarted. To check or change the crane configuration, press on the Operating Mode Selection button on the IC1 screen. This screen will appear with the parameters which are relevant to the operating mode or crane configuration. These parameters must be selected by the operator that corresponds to the actual status of the crane. The load limit device can reliably monitor the crane operation only if the entries are correct. Next, we will look at the crane operating console for monitoring. At the top of the screen are the engine and filter monitors. This includes the engine, battery indicator, coolant level, air filter, hydraulic filter, and hydraulic level. If any get out of range, the indicator light will show red. In this area is where fault zones will be displayed. Please note that a list of all the fault codes can be found in the operator's manual. On the right-hand side of the screen is the current engine data and level indicators, including engine speed, engine temperature, and fuel. Each are toggle switches to see engine oil pressure, voltage, and hydraulic oil temperature. Engines that are in accordance with Exhaust Emission Standard EM4 EPA Tier 4F will also have an AdBlue indicator for engine faults, low AdBlue, and LIM indicator. Each of these can be switched between graphic and numerical values. Below this is our hour meter and lever control modes. The left-hand side of the screen shows the operating controls for all three levers. Each will have the slew control at the top, followed by each winch that the levers control and the percent at which each winch is being utilized, from 0 to 100%. The bottom row is to operate the reeving winch, slew, and superlift hydraulics. Now let's move to the LLD monitor. To start crane setup, press this button, which will take you to this screen. First, we will set up an RZ1. Once this button is pressed, there will be several parameters that you will need to set up, including boom combination and boom length. It is important to note that if the number values are in red, they must be confirmed. The TYP button is for boom combination. Second is the boom length, followed by the fly jib height, fly jib length, the angle of the fly jib, and the angle of the fly jib for LF only. To add the parameters for any of these functions, push the caret on the far right side of the button. There you will get a pull-down menu to add values. Once parameters are added for RZ1, press Save. Next, add the values to RZ2. This screen includes settings for the central ballast, counterweight on the superstructure, superlift counterweight dolly and frame, superlift counterweight, and radius of the superlift mast point. As with the RZ1 screen, you will need to walk through each menu that applies to your crane setup. Once again, make sure and save your inputs. In the RZ3 menus, there are settings for number of sheave sets fitted to the sheave head and reeving of the main hook. Save and exit. Then hit OK. The screen switches to the LLD screen. At the top of the screen are the symbols for all the functions that were selected and the values for each, as well as a visual representation of the crane in its present configuration. Below this are symbols for menu switchover and LLD bridging, as well as error codes. This bar is a continually changing display for percentage of workload. Below this is active load, the total load including hook block, hoist rope, and load handling device. And last is the maximum load for the current crane configuration. It is important to note that you can view tables for your configuration in the LLD screen. Next, we will look at the operating range limits. To do this, press this button in the menu area. The areas that are shown in green are active, such as the main boom angle, slewing angle, workload, working radius, boom angle limitation, as well as an operating range top view and more. To set each, move the crane to the desired limit and press the appropriate button. Then move the crane to the next limit and press the next button. Press the switch to save. You will need to do this with all the limits for the different functions. Please note that all settings will be saved until they are reset or removed. It is important you check these settings each time the crane is started. To check ground pressure, you will need to press this button. This will show the relative distribution of the ground pressure along both track carriers. Make sure that the track width is correct for the crane, and if the width needs to be changed, press this button. After returning to the main menu, one optional function is the loggers. This function calls up data logs from the LLD screen or wind logs. This information can be downloaded onto a USB stick drive. Once the crane is set up, there is a lot of visual information about the crane on the LLD screen. On this screen, you can see all the different boom and weight values, including sheave head height, boom angle, load radius, and derricking rope force, current and maximum. Please note that this is just an overview of the IC1 and LLD systems. There are several different configurations and options that are available on the CC24.400-1. Consult the operator's manual for full details on the crane's operation systems. This section will cover the disassembly process of the CC24.400-1 Tadano crane. As with the assembly process, safety should be at the forefront of everything that we do. Always wear the appropriate PPE and anti-fall protection at all times, and avoid all pinch or crush points. To start the disassembly process, lower the block to the ground. Then remove the anti-2 block and replace pins. Lower the boom so that personnel can safely access the rope sockets so they can be removed from the head. Remove the rope from the sockets and replace pins and keepers. Next, remove the rope guards from the block. Once the rope has been removed, reinstall the guards for transport. Next, remove the rope from the sheave. It is best to use 2 people, so one can push and one can pull the rope. Swing the boom so that it is not over the block. Place the boom head on wooden blocks for further disassembly. Once the boom is secure, loosen the forward rope guard on the head and pin in the forward position. Remove all electric and communication cables from the head, making sure to cap all connections. Roll the cable up and stow on the proper storage location. Remove and store the anemometer for future use. Next, roll all the electrical and communication cable for the boom. To do this, disconnect from the superstructure and cap all connections securely. Detach from the boom and roll all cable onto the spool. Once all the cable has been completely spooled, it is important to lock the spool tightly with this lever. Then unhook all hydraulic hoses from the boom base and make sure all caps are installed and sealed tightly. The boom head will need to be removed next. To do this, slightly lift the boom. Then lower both boom support legs by turning the hand crank. Line up the holes at the lowest position and pin into place. Next, lower the boom supports onto wooden blocks so that the head is slightly off the ground. With the boom supported by the boom support legs, use the reeving winch to roll the rope to both drums. First, select the winch on the IC1 control panel and use control lever 3 to slowly unroll the reeving rope, using personnel to keep slight pressure on the rope. Once an adequate length has been reached, pin the reeving rope to the drum rope. Personnel will need to be on the boom to make sure that the rope runs freely. As always, personnel will need to be in the proper PPE and connected to fall protection at all times. Make sure that personnel on the boom remove the rope guard on the top sheaves of the head to allow the ropes to move smoothly. Slowly tighten ropes and begin pulling the lifting ropes back to the drum. It is important the rope does not snag on the top of the boom and that the rope tension is steady. Once the ropes have reached the drum, disconnect the reeving rope. Then, using straps, secure the rope to the drum for transport. To prevent accidents, the engine must be switched off during this process. When retrieving the reeving rope back to the head, have personnel continue to keep slight tension on the rope as it moves back down the boom. To help with reeving, a tip is to tie a cotton rope to the reeving rope to help control the fallover at the top of the sheave on the head. Repeat the retrieving process for the additional drums. Once all ropes are reeved and secured to the main drums, reeve and secure the reeving rope as well. Now that all ropes are secure, unpin the stay bar from the A-frame. To do this, on the LMI, switch the operating mode to RGO. Then lower the A-frame so that personnel can unpin the stay bar from the A-frame. Make sure to secure pins and keepers for transport to the next job site. Unpin each section of the stay bar and secure to the boom section for future use. For the head, use this lever to take the tension off the pins. Remove pins and secure. Our next step will be to remove the head. Connect the shackles and lifting ropes to the designated lifting points on the head. Remove the bottom connecting pins first using the mobile hydraulic power pack. Lift the head slightly and then remove the top pins. Once all pins are removed, slowly remove the head. Next is the removal of the boom sections. First, connect the shackles and lifting ropes to the designated lifting points on the boom section. Then raise the support legs on the boom. To do this, lift the boom slightly and use the hand cranks to raise the supports to the highest pinning position. Pin and secure with keepers. Use the mobile hydraulic power pack to retract connection pins for the boom section, and slowly lift and move the boom section. Once all boom sections are removed, the boom foot will need to be removed. To do this, connect the shackles and lifting ropes to the designated lifting points on the boom section. Then, prepare to remove the boom foot pins by connecting the Quick Connect hydraulic hoses from the mobile power unit to the connections on the boom foot pin activators. Remove both locking pins and make sure the stop valve is in the open position. Then, retract the pins from the superstructure to the boom foot. Replace pins and keepers and remove Quick Connect hoses. Slowly lift the boom foot off the superstructure. Once the boom foot has been securely placed on the ground, the handrails need to be lowered for transport. When doing this, personnel must be tied off at all times. Make sure all pins are secure and the handrails are in the down position for transport. Now, the counterweights and counterweight trays will need to be removed. To do this, first release the tension from the clamping bolt on top of the counterweight stack and pull the assembly chain through the hole in the center of the counterweights. As with the assembly process, it is important that the counterweight trays stay as balanced as possible. Start by removing one counterweight, then two at a time, making sure that there is only one counterweight difference on the other side of the superstructure. Next, remove the counterweight trays, but first remove the lower pin that holds the tray to the superstructure. With the counterweights removed, remove the handrails and ladders and secure for transport to the next job site. Lower the catwalk, making sure to watch for pinch points on the brackets. Fold and secure catwalks with pins and keepers. The track frames will be next, but first, remove all steps for the track frames. On the LLD screen, change the operating mode to SMAB1. Activate the radio remote controller and activate the Assembling Chassis switch on the LLD screen. Also, tilt the cab back by pushing this button on the back of the left console. Using the remote controller, raise the outriggers to lift the tracks off the ground. Then remove the track frame pin caps and store for transport. Disconnect electrical and hydraulic connections from the track frame, making sure all caps and hoses are securely stowed for transport. Now, rotate the superstructure so the A-frame's assembly cylinder is hanging in the center of the crawler track carrier. Secure the slings to the designated connections on the crawler side frame using the supplied shackles. It is important to only attach to the designated connection point to prevent damage to the tracks. Once the connections are secure, slowly retract the assembly cylinder by moving the control lever 3 until sling ropes are tensioned. Carefully position the protective sleeves that are mounted on the slings between the track pads to protect against damage during lifting. Note that free lifting of the track frame with the derricking gear is not permitted, and you must adhere to the lifting guidelines. Using the remote controller, press the 1 and 11 buttons, and the pinning cylinders on the crawler track carrier will retract. With control lever 3, lift the track frame. Using control lever 2, move the track out and away from the car body, keeping in mind your maximum lifting radius of 6 meters or 19.7 feet. Rotate the superstructure and remove the opposite side track frame. Once the tracks are removed, slowly lift and remove ballast weights one at a time. Do not remove both ballast weights at once. It is important to note these weights can only be placed within 5.5 meters or 18.04 feet of the superstructure. The maximum A-frame angle is 62.7 degrees. The maximum permitted load is 25 tons. The slewing area of the superstructure is 360 degrees. Once all ballast weights have been removed, retract the hydraulic cylinder on the A-frame in preparation for folding back the A-frame. Switch the operating configuration to RGO. Activate the radio remote control to the pre-select assembly function, fold over A-frame. Before folding over the A-frame, the rope guard on the front of the sheave must be removed to prevent damage to the derricking rope. Start by fully extending the hydraulic cylinders. Then slowly move control lever 3 back until A-frame is lying on the cylinders. Using the remote control, activate buttons 2 and 7 to retract the cylinders until the A-frame is in the transport position. At this time, add the transport lock on the cylinder and add the rope guard to the sheaves. With the A-frame secure, the last thing is to prepare the cab for transport. First, remove the handrail and fold up the catwalk behind the cab and secure. Then loosen the tension rod for the cab and remove the holding pin. Rotate the cab in front of the superstructure and secure into the transport position. The CC24.400-1 is now ready to be transported to the next job site. This is a brief overview of the crane disassembly process and is not a substitute for the operator's manual. Please consult the operator's manual for full details on the disassembly process.